Okay, everyone. So let's begin then. So we were doing trigonometry, and we are done with most of the concepts that are in our O-level math syllabus in this. There's one last concept that we have left as far as the O-level syllabus is concerned. But then there are some other things as well for IGCSE, which we will continue with today. This is the last concept as far as the O-level math syllabus is concerned. That is obtuse angles. Let's take an example of this. First of all, we need to understand the terminologies that we have as far as different angles are concerned. So if you have an angle that is between 0 degrees and 90 degrees, there's a name that we have for angles like this. Angles like these, we call them acute angles. So angles that are between 0 and 90, we call them acute angles. And then angles that are between 90 degrees and 180 degrees, these angles are known as obtuse angles. And then finally, angles between 180 degrees and 360 degrees, these angles are known as reflex angles. Okay. You need to be aware of these names of different types of angles. Acute and obtuse are the two that you will be using more often, but sometimes you will see reflex being used as well. Okay, you need to know the names that we have for these angles. Now, in this topic, we are going to restrict ourselves to acute and obtuse angles. Basically, what happens is, if you have an angle like this, if I have a straight line like this, and on this straight line, there's some angle, let's say this is an angle, theta. Now, what is this angle theta? This is an acute angle, right? It's less than 90. 90 would be this angle, right? It's less than 90. This is an acute angle. Now, on the straight line, the angle on the other side of the line, the angle that you see on this side, the remaining angle, what is that going to be? That's going to be 180 degrees minus theta, right? Because angle in a straight line is 180 degrees. If this angle is theta, what's this angle? This is 180 minus theta. Now, if we consider these two angles, the one in blue here and the one on the side, one on the right side here, one of them is acute and the other is obtuse. Now, these angles have a relation with each other. One is acute and the other is the corresponding obtuse angle for that. These two angles are basically related to each other. Now, how are they related? Let's do this exercise. Let's try to understand it using some examples. Let's say the angle theta here, let's say that is equal to 45 degrees. Okay, that's an acute angle. Let me actually use another angle. Let's say 60 degrees. This is an acute angle. Okay, 60 is an acute angle. Now, if theta is 60, what about this 180 minus theta angle? 180 minus theta, that would result in 120 degrees. So if one angle is 60 and the other is 120, we can say this is the acute angle and the corresponding obtuse angle for that would be 120 degrees. Now, the sine, cos, and tan ratios of these two angles, they are basically connected to each other. How exactly are they connected? If you were to find sine of 60, you can try this on your calculator and see what you get from that. Sine of 60. Let's see what the result that we get from this. Sine of 60. That's giving me square root of 3 over 2. Okay. Now let's find sine of 120 and see what that turns out to be. Sine of 120. That is also square root of 3 over 2. So if we have an acute angle and the corresponding obtuse angle for that, so basically two angles that have a sum of 180, the sine ratios of both of those angles are always going to be equal to each other. They're always equal to each other. You can try any other angles. You can say sine of 30 degrees. If there was one angle that was 30, what would this ratio be? Again, you can put this on a calculator. Sine 30 is going to give you 1 over 2. Okay, you can try that. Sine of 30, that is 1 over 2. All right. Now, what's the corresponding obtuse angle for this? If acute is 30, 180 minus 30, what would that be? That would be 150 degrees. Again, you can try evaluating that from on your calculator and see what that is. That's also 1 over 2. So if you have two angles that add up to 180, if you have two angles that add up to 180, the sine ratios for both of them are always going to be the same. And we can write this in this form. We can say sine of 180 degrees minus theta, that is always equal to or identical to sine of theta. Okay. In case theta is an acute angle, then this angle would be an obtuse angle. If theta is obtuse, then this would be acute. Either way, these two are both going to be equal to each other. All right. Now you can try the same thing with other ratios as well. You can try it for cos, you can try it for tan, and see what they result in. So in this case, we tried sine of 60, sine of 30, and the corresponding obtuse angles for them, they turned out to be the same, right? Now, we can try the same two angles. So let's say theta is 60 or 30, any one of them, and see what happens for other ratios like cos and tan. So cos of 60, for instance, you can try that. You can see what that is, cos of 60. You will see that this results in 1 over 2. And now, what's the corresponding obtuse angle for that? Corresponding obtuse angle for 60, 180 minus 60, what would that be? 120. So cos of 120. You can try this on a calculator as well. And you see what that turns out to be. This is negative 1 over 2. All right. So the numerical value is the same, but the sign is different. So for obtuse angles, cos is negative. For acute angles, cos is positive. All right. This can be written like this. We can say sine, or in fact, cos of 180 minus theta, that is the same thing as minus cos of theta. So if we have cos of an obtuse angle, it would be negative of the cos of the acute angle. That's the only difference. If this is 1 over 2 for the obtuse angle, we just add a negative sign to that, and that's it. And it's the same thing for tan as well. If you were to do tan of 60, put this on a calculator, that should give you square root of 3. And the corresponding tan of the tan of the corresponding obtuse angle, which is tan of 120, you would see that is also square root of 3. The only difference is that it comes with a negative sign there. Okay. So for that as well, you can write down this identity. Tan of 180 minus theta, that's the same thing as minus tan of theta. So we have these three identities. The first one is the one that's most commonly tested. cos and tan ones are rarely tested, but sine one is tested a lot. You need to keep this in mind. Sine of the obtuse angle is the same as the sine of the corresponding acute angle. There's no difference. Cos and tan are also the same. The only difference is that they come with a negative sign. You can remember it like this now. For acute angles and obtuse angles, for sine, cos, and tan, acute angles are all positive. The sine, cos, and tan of them, they're all positive. For obtuse angles, sine is positive, but cos and tan are negative. Okay. Now, why do you need this when you can put this on your calculator? Sometimes it will come in the non-calculator paper. So you might be given the value of, let's say, if you know that sine of 75 degrees is equal to something, let me just find that from here. Sine of 75, so they might tell you sine of 75 equals 0.966 to three significant figures. They might tell you this, and then they might ask you to find sine of 105 degrees. Now, how can you do that? You're given sine of 75, and they're asking you to find sine of 105. Now, if you could use a calculator, you could just do it using a calculator. But in the non-calculator paper, you would not have access to a calculator. How do you find it in the non-calculator paper? You say 75, its corresponding obtuse angle is 105. These are two angles that add up to 180 degrees. So whatever is the sine of 75, sine of 105 is going to be the same as well. That is also going to be 0.966. You can write it directly without using a calculator because they add up to 180. If one is this, the other also has to be the same. Okay. However, if they replaced it with something else, let's say they gave you that cos of, so if they tell you that cos of 45 degrees is square root of 2 over 2. And they want you to find cos of 135 degrees. How can you do this now? Again, this is the acute angle, 45 degrees. What's the corresponding obtuse angle to this? You see, if this angle is 45 degrees, the angle on the other side here, what is that going to be? 180 minus 45, which is 135. So both of these angles, they add up to 180. When that is the case, we know the values are going to be the same. Numerical values are going to be the same. So cos of 135 is also going to be square root of 2 over 2. However, we know that cos and tan of obtuse angles, they are negative. So we will put a negative sign with that. And that's our final result. So we can write down these values directly like this. Okay. Does that make sense? So this is how this concept is sometimes tested. You need to remember that, let me actually write that down here. If two angles add up to 180, their sine, cos, tan ratios they have the same numerical values. They have the same numerical values. Numerical value means if you ignore the negative sign, this number here, that is going to be the same. You're going to have the same numerical value. The only difference is for acute angles, sine, cos, tan are going to be positive. And for obtuse angles, for sine function, both of them are positive. Write that here. Yeah. So if two angles add up to 180, their sine, cos, tan ratios have the same numerical values. The only difference is for sine function, they are going to be exactly the same. For cos and tan, with obtuse angles, we would have negative signs. With acute angles, we would have positive signs. That's the only difference. Okay. And this is how it is sometimes tested. They will give you one ratio and they will give you sine, cos, or tan for the acute angle, and they might want you to find it for the obtuse angle. Or it could be the other way around as well. They might tell you, for instance, if tan of 120 degrees, let's say that is equal to minus square root of 3. And you might have to find tan of 60 degrees. Now, again, is the condition satisfied here? One angle is 120 and the other is 60. Do they add up to 180? They do. That means tan of 60 should also have the same numerical value, which is square root of 3. Now we know when tan is acute, when the angle is acute, tan is positive. So instead of being a negative value, all that changes is this is going to be positive. Okay, now for IGCSE students, it will become clearer when we talk about graphs as well. But for all of the O-level students, you will need to remember this, that this is how it happens. For sine of acute and obtuse angles are both positive. Cos and tan of obtuse angles, they are negative. All right. Okay. Let's have a look at a couple of examples on this quickly before we move on to graphs. Let's have a look at this. This is not testing that. Let me look for an example where we might have to use that idea. Okay, let's look at this. This is part 3 of a question. It does not look like it's related to the previous part. So let's just focus on this. It says, okay, it is related to the previous part because they're talking about triangle ABC. Let's look at another question instead. Okay, let's try this. This is question number 3 from the obtuse angles worksheet. It says AB is equal to 8 centimeters, AC is equal to 11 centimeters, and DC is 6.5 centimeters. The angle BAD is 26, this angle is 30 degrees. In the first part, just say calculate BC. Okay, what's the length BC? AC is 11, so this point is C here. That is kind of not visible. There's some printing issue most likely. This point is C, okay? Now we are looking for the length BC. This is the length that we are looking for. How can we find this? We have two sides of the bigger triangle. We know that one side is 8 and we know another side is 11. And we know the angle between those two sides. This complete angle is 56 degrees. It's a classic cosine rule case. You have two sides given and the angle between them given. You'll have to use cosine rule here. Sine rule cannot be used because you don't have any side angle pair in this case. So if we use the bigger triangle, the one that I've highlighted in yellow here, what I can do is BC squared. So using cosine rule goes like this: a square equals b square plus c squared minus 2bc cos of a. So bc squared, that equals 8 squared plus 11 squared minus 2 into 8 into 11 times cos of this angle, which is 56 degrees. It has to be the angle that's opposite to that side on the left side. So that's 56 degrees. You can calculate and see what this turns out to be. 8 squared plus 11 squared minus 2 times 8 times 11 times cos of 56. So on the right side, I'm getting 86.582. That's BC squared. You can take square root on both sides now. And that gives me 9.30 to three significant figures. That's the length of BC that I'm getting from this 9.30. Okay, so that's the first part. Now in the second part, they say calculate the obtuse angle ADC. Okay, so they want us to find this angle now. This is ADC, this angle here. Okay, now for this, we have to use the smaller triangle, like this triangle. Now in this triangle, what information do we have? We have one side, that's 11. We do not know the opposite angle, but we have this side and we know the opposite angle to this. So we have one side angle pair. And for another pair, we know the side and we just do not know the angle. Okay, now how do we deal with this? We can use sine rule in this case because we have a side angle pair given and we have to find something missing from the other angle, from the other side angle pair. What do we do for this? We can say sine of 30. So you can use any variation of the sine rule, right? So one variation is A over sine A equals B over sine B equals C over sine C. Or you can also write the same thing as sine A over A equals sine B over B equals sine C over C. Okay, so I'm sorry, this is B here. B over sine B equals C over sine C. That's one way to write the sine rule. Or you can also write this as sine C over C with the angles on top and sides at the bottom. It doesn't really matter. You can use any of them. Usually it makes things simpler if what we have to find out, we keep that in the numerator. So what are we looking for? We're looking for the angle D. Okay, so I can write it like this. This is one way to do it. Sine D over the opposite side, which is 11. D is basically this angle ADC. Or what we can do is we can just call this theta for now. The angle that's missing. That equals sine of 30 divided by 6.5. And what we can do now is we can find the value of theta from our calculator. Sine theta equals 11 sine 30 divided by 6.5. So I can just take this 11 to the other side, multiply it there. And now on my calculator, I'm getting 11 sine 30 divided by 6.5. And on the right side, I have 11 over 13. So sine theta equals 11 over 13. Okay, now what's the value of theta that we get? Sine inverse of this number, and that is giving me 57.7957. We can say that's 57.80 degrees. That's the value of theta that we're getting. But now we've got to be careful. The question says calculate the obtuse angle ADC. So they're telling us this angle here is supposed to be obtuse. It's not an acute angle. Okay. We are getting an acute angle. What's the corresponding obtuse angle to this? The corresponding obtuse angle would be 180 minus 57.8. You can see what that is. That will be the angle ADC. This turns out to be 122.2 degrees. That's the answer that you write there. 122.2 degrees. Right? That's the angle that we were looking for. That's the angle ADC. Now, sine inverse of this number actually gave us 57.8. So calculator is only going to give you the acute angle. But we know from what we just discussed, sine of this angle and sine of this angle, they are going to be the same, right? Because they add up to 180. And we know that sine of acute and obtuse angles, they are the same. They're equal to each other. So if sine of 57.8 is 11 over 13, sine of 122.2 is also 11 over 13. So To find the obtuse angle, all we have to do is just subtract this number from 180 and we get the corresponding obtuse angle. Okay? Okay, I'm sorry, I got disconnected. Can you hear me again? Okay, you can see my screen again as well, right? Yeah, okay. All right, so that's the idea. If they're looking for an obtuse angle, all you have to do is find the angle like we normally do, and then subtract that from 180, and we will get that angle. All right, so that was one small thing that was left. In the O-level syllabus, as far as the O-level syllabus is concerned, that's all trigonometry that we have. Okay. But now there are some more concepts that you have in the IGCSE syllabus. All right, so that's what I want to continue with today. So first of all, there are some values of sine, cos, and tan that they expect you to remember. Okay, they expect you to memorize some values of sine, cos, and tan. Now, if you had when you had calculator allowed, in that case, you could just do it on your calculator, and that will be okay. But in the non-calculator paper, for the non-calculator paper, they expect you to memorize these values. Okay. Now, let me write those values down here. What I'll do is I will add a section here, additional concepts for only the IGCSE syllabus, IGCSE extended syllabus. Okay. Now, the first thing that IGCSE students need to be able to do here is they need to be able to write down exact values of some ratios, exact values of some trig functions, or exact value of trig functions for some angles. Okay, now what are those angles? Let me write them down. So these are some common angles: 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. You need to remember the values of sine, cos, and tan for these specific angles. Okay, you need to memorize these values. Now, I'm going to first write down the values, and then I'll tell you a way to remember them. Okay. First, I'm going to write down the values for each one of them. Sine of 0. So how are you going to read this table? If you have this number 60 here, then the value here is going to be sine of 60. Okay, the value here is going to be sine of 60. If I write this, I write a number here in this box. This value is going to be cos of 90. Okay. Let me write down these values now. Sine of 0 is 0. Sine 30 is 1 over 2. Sine 45 is square root of 2 over 2. Sine 60 is square root of 3 over 2, and sine of 90 is 1. And then cos of 0 is 1. Cos of 30 is square root of 3 over 2. Cos of 45 is square root of 2 over 2. Cos of 60 is 1 over 2. And cos of 90 is 0. And then tan 0 is 0. Tan of 30 is square root of 3 divided by 3, or another way to write that is 1 over square root of 3. Tan of 45 is 1. Tan of 60 is square root of 3. And then finally, tan of 90 is basically undefined. These are the values that you need to memorize for the IGCSE syllabus. Okay, you need to memorize these values. Now, how do you do that? If you had calculator allowed, you could just put these values on the calculator. You could just find these values from the calculator directly. However, in the non-calculator paper, since you can't do that, you will need to memorize these values. Now, how do you do that? There's this trick for this that you can use. Let me show that to you. You can use that trick to remember these values or use any other way that you like. However, the point is that you will need to memorize these values. Okay. In the calculator paper, you can use them from your calculator directly. In the non-calculator paper, you will have to be able to recall them. Now, the way to do this is, you remember that these are the common angles: 0, 30, 45, 60, 90. These are 5 angles in total that for which you need to remember the sine, cos, tan values. All right, 5 angles in total. What you do is you write down numbers 0, 1, 2, 3, 4 in front of sine like this. So you start from 0 and then you write down numbers 1, 2, 3, 4. 0, 1, 2, 3, 4. All right. Now, with all of these numbers, you would have 0 in the 4 in the denominator. So you divide all of these numbers by 4. So you say 0 over 4, 1 over 4, 2 over 4, 3 over 4, 4 over 4. Okay, so let me repeat. You write down the angles 0, 30, 45, 60, 90. These are the 5 common angles that you have. And now, to remember how to figure out their sine values, what you would do would be you would write these numbers like this: 0, 1, 2, 3, and 4. Okay. Now, once you've written those numbers, you divide all of those numbers by 4, and then you take square root of that whole thing. You take square root of that whole thing. This is what you do. All right. You write numbers 0, 1, 2, 3, 4. Let me show that to you here now. So I can write down the actual values using this now. You write numbers 0, 1, 2, 3, 4 in the first row. Divide all of them by 4 and then take square root. Okay, now what's the first value? 0 over 4, that's a 0. So sine of 0 is therefore 0. Square root of 1 over 4, what should that be? Square root of 1 over 4, that's 1 over 2, right? Square root of 1 is 1, square root of 4 is 2. So you get 1 over 2 for this. Sine 30 is 1 over 2. All right, then what about 2 over 4? If you do the cancellation, you do cancellation like this, or you can just do it directly as well without doing cancellation. It would look like this. In the numerator, you have square root of 2. In the denominator, square root of 4, that's just 2. You can write it like this. That's sine of 45. What about this? In the numerator, you have square root of 3. In the denominator, you have square root of 4, which is 2. So this becomes square root of 3 over 2. And then finally, 4 over 4 is 1. Square root of 1 is 1. You get sine of 90. These are the values of sine 0, 35, 45, and sine 0, 30, 45, 60, 90. All right. Now, once you've written the sine values, cos values are just going to be the same values in the reverse order. Okay, so you start from 1. This is going to be the first value. That's 1. Then the second value is going to be this, square root of 3 over 2. Third value is the same, square root of 2 over 2. Fourth value is this one, that's 1 over 2. And the fifth value is 0. These are the cos values. Okay, so you just write down the same values in the reverse order once you figured out the sine values. Okay, or you could figure them out again like this. You would say write numbers from 4, 3, 2, 1, 0 like this. Divide each of them by 4. That will be for cos, right? So it's just the opposite of that. For sine, we are doing this 0, 1, 2, 3, 4. For cos, we just do the opposite 4, 3, 2, 1, 0. Divide all of them by 4, take square root, and you can write down the cos values for each one of them like this. So they're just going to be the same values in the reverse order. And then what about tan? For tan, you can remember this. Tan of theta is actually the same thing as sine theta over cos theta. So whatever is the sine value and whatever is the cos value, you divide both of them. So you say 0 over 1. 0 divided by anything is 0, so you get 0 here. 1 over 2 divided by square root of 3 over 2. Now let's try that. 1 over 2 divided by square root of 3 over 2. 2 and 2 get cancelled, and we're just left with 1 over square root of 3. All right. Then square root of 2 over 2 divided by square root of 2 over 2, they are both the same. That's just 1. Square root of 3 over 2 divided by 1 over 2, what would that be? Square root of 3 over 2 over 1 over 2. 2 and 2 get cancelled, and we're left with square root of 3. 1 over 0, that's undefined. You cannot divide by 0. This is not possible. These are all the values of sine, cos, tan that you need to remember. 0, 30, 45, 60, and 90. Okay? You will need to memorize these values. Now, how are they going to be used? You could have any triangle in which you have these angles, and you would have to write down the answer in exact form. Exact form means in square root form or fractional form without using any decimals. How would that work? Let's take an example of that. You could have a triangle that looks like this. Let's say you have this triangle in which you are given that this side is perhaps 8 and this side is 11, and the angle between these two sides, that is 30 degrees. No, Akif, this is only part of IGCSE syllabus. So we're done with the trigonometry. That's part of the O-level syllabus. Okay. But there's some concepts that are only in IGCSE. That's what we're discussing those right now. So this is not part of O-level syllabus. For O-level, you do not need to memorize these. Okay. But for IGCSE, you have to remember these values. Now, how are these values going to be used? They're going to be used like this. You have a triangle like this, and you want to find the area of the triangle. Area of this triangle. What's the area of triangle? Half into base into height. That's one way to find the area of the triangle. Another possibility is you can use half AB sine C, right? In this formula, you need two sides and the angle between them. Now, do you have two sides? You have 8 and 11. Okay, so you can use them. You can say 1 over 2 times 8 times 11 times sine of the angle between them, which is 30 degrees. And now, if it comes up in the non-calculator paper, how do you know what sine 30 is? What's the value of sine 30? You'll need to remember this. Sine 30 is 1 over 2, right? Sine 30 is 1 over 2. And I told you one way to remember this, although these are not many different values, for sine and cos, just remembering the possible values, you can just put them here like this. Once you've done some practice, you'll basically be able to recall all of these values directly, because these are just a few values, a few unique values, because you've got 1 over 2 here, and you've got 1 over 2 here as well. So sine 30 and cos 60, they're both the same. Sine 45 and cos 45, they're also both the same, square root of 2 over 2. And then sine of 60 and cos of 30, they're also both the same. So once you've done some practice, you will tend to remember them anyway. But if you can't remember them right away, this is the way to do them. I told you how to write them down like this. If you want to do it like this, sine of 30, you know that this is 0, this is 30. You start from 0 and then you write 1. Okay, so this is the number that you're looking for. You divide 1 by 4, take square root. What do you get from that? 1 over 2. So sine 30 is supposed to be 1 over 2. You can just input that value here now and you get your result. The area of this triangle is going to be 8 times 11. 8 times 11 is 88 divided by 4. That will be 22 squared units. That's the result that you get. Or you could do some cancellation first to make it simpler. 2 times 11, that's just 22. That's the area of this triangle. Okay, so you'd have to use these exact values like this. Let me just give you one more example in this quickly. Let's say you have a right angle triangle like this. So you have a right angle triangle like this. And in this right angle triangle, let's say you know that this angle here is 60 degrees. Okay, now it's a right angle triangle, and we know that this side here is 15. And what you want to do is you want to find the side on the other side, this. You want to find x. Now, how do you do that? X is perpendicular, 15 is hypotenuse. So you say perpendicular over hypotenuse, that equals sine of 60. And now again, if it is in the non-calculator paper, you need to be able to recall this value. What is sine of 60? The common angles are 0, 30, 45, and 60. Okay. So you write numbers like this, 0, 1, 2, 3. This is the one that we're looking for. Divide that by 4, take square root. That's the number that you have. This is square root of 3 over 2. So you say x over 15, that should equal square root of 3 over 2. And now x equals 15 square root of 3 over 2. And that's your final answer. You leave it like this. This is the length of this side that we were looking for in exact form. Okay. So that's another thing that you need to know, need to be able to do for IGCSE syllabus. You need to be able to write down sine, cos, and tan of all of these values directly. All right, and I told you the way to remember them. For sine, you write down numbers like this: 0, 1, 2, 3, 4. Divide them by 4, take square root. For cos, you write numbers in the opposite order: 4, 3, 2, 1, 0. Divide each of them by 4 and take square root. For tan, you do sine over cos. All right, make sense? Any issues with this? Any problems with this? Okay, good. Let's move on then. Now, the next thing that you need to know, again, for IGCSE syllabus is graphs of trigonometric functions. Graphs of trig functions. So you need to be able to sketch graphs of sine, cos, and tan. Now, again, they can come in the calculator paper or in the non-calculator paper. Now, first of all, since we're doing it the first time, what I'll do is I'll calculate these values from you using a calculator. And then we will try to remember the shape of the graph after that. Okay. Now, let me explain what I mean by that. So let's start with the sine function first of all. So we want to draw the graph of y equals sine of x. Now, how can we do this? We will have to draw this for the interval from 0 to 360. Okay, 0 to 360, we'll have to draw this graph for this interval. 0 degrees to 360 degrees. All right, now, like you generally draw any graphs, you make a table for x and y values. You can start with that. How do you make a table for this? From 0 to 360, you need enough values. We normally divide these values taking an interval of 90 degrees. So we have 0, 90, 180, 270, and 360. All right. But since we're doing it the first time for now, to understand the shape of the graph better, we can take some extra values as well. But once you've done this a couple of times, these values are going to be enough. But since we're doing it the first time for now, let me take some more values and break it down even further. Let's take an interval of 45. 45, 90, 135, and then 180 is, after 180, it should be 225, and then finally 315. Okay. Now, if it's in the calculator paper, all I have to do is put this in the table function on my calculator. Okay, it's going to take a few seconds. All right. Now, the way to do this is we will be using this table function in the graphs topic later on as well. You go to menu and you have this table function option here. You press the table function option. Now, this is the function that we have to input, y equals sine of x. You input that function here, sine of x. Now, where's the x button? On this calculator version, I have it on top right, this button on top right. This is x. I can use x from there. In other calculator versions, you will always find it above this bracket close button. So see the button above the delete button, the bracket close button. On top of that in red, you have X written. If you want to access it from there, you can press alpha and then press the bracket close button. You can you can input X using that button as well. So what I do is I say, okay, this is the function f of x equals sine of x. Press the equal button again. This is giving me an option of g of x. That's basically for sketching two functions at the same time. We would normally not need to do that for now. So I can just skip that. How do you skip that? Just press the equal to button again. Okay. Now, in order to sketch this graph, we start from 0. So the start has to be 0. End at 360. Step means the gap that you want between the values, right? What's the gap between the consecutive values that you have? It's 45 degrees. Let's put 45 there. And you see, you'll have a nice table that shows up there that gives you all of these values. So if x is 0, y is 0. If x is 45, y is 0.7, right? Approximately that's the value. If x is 90, y is 1. If x is 135, it's 0.7 again. If x is 180, y is 0. If x is 225, y is minus 0.7. When x is 270, y is minus 1. At 315, it's minus 0.7 again. And at 360, it is 0 again. So what I can do now is I can plot these values on a graph like this. So I have x and y axes like this. This is the y-axis, this is the x-axis. Let's plot those values. So we start from 0 and we have to end at 360. You see the maximum value, the maximum y value is going up to 1 here. And the minimum y value is going up to -1. So on the vertical axis, you can take a scale like this. You can say this is 1 and this is -1. Let's plot those values now. For that, on the horizontal axis, we can break it down like this. We can say this is 180, and then break that into half again. This is 90, this is 270, and then we have 45 degrees intervals within those points as well. Okay, what's the first point that we're getting? At 0, we've got 0. Let's mark that here. At 45, 0.7, so roughly it's going to be around here. At 90, it's 1. At 135, it is 0.7 again. At 180, it's 0. At 225, it's negative 0.7. At 270, it's -1. At 315, it's -0.7 again. And at 360, it is 0. This is the graph. These are the points that I'm getting. And now I can just join these points like this. What's the graph that I get from this? The graph looks like this. It's a curve of this form. This is what the graph looks like. Okay. You have X and Y axes like this, and this is what the graph looks like. From 0 to 360, this is the sine graph. All right, this is the sine graph. Again, this is something that you will need to remember, because if it comes up in the non-calculator paper, you need to be able to draw this. And how do you draw this? You need to remember the shape of the graph. And you need to remember that it starts from 0, and then it goes to 1, and then then 0 again, and then -1, and then 0 again. You need to remember the points on this graph. Okay, so it will come exactly like this. Sine x graph, this is what it looks like. Okay. Any problems with this? Any questions on this? No? All right, so you understand the shape of the graph. It's a curve like this. And if you were to extend it beyond these points, although that's not going to be required in general, but in your syllabus, if you wanted to extend it, this shape actually just continues like this on both sides, right? It just continues like this on both sides, the same way. The same pattern continues. But you would have to draw it from 0 to 360. This is what the graph is going to look like from 0 to 360. You need to remember the shape and the points that you have here. Okay, now these are the important points. At 0, it's 0. And then at 90, it is 1. At 180, it is 0. At 270, it is -1. And at 360, it is 0 again. Okay, once you have these points, you can just remember this is the shape of the graph. The shape of the graph is going to be like this. For sine, it starts from 0, goes up to 1, then comes back to 0 again, then goes to -1, and then comes back like this. You need to remember the shape of the graph and these points 0, 1, 0, -1, 0 at 90 degrees intervals. Now you can do the same thing for cos as well and see what that graph looks like. Y equals cos of x. Okay, let me draw x and y axis like this for the cos graph. You've got the y-axis here, and you've got the x-axis here. All right. Now, for the cos graph again, what we can do is we can make a table. And this time, let's take a few less values. We know that it's going to be a curve. But let's learn how to draw it without taking so many values and just do it using a few values instead. So instead of taking values at 45 degrees intervals, what I'm going to do now is I'm going to take values at just an interval of 90 degrees. Now, again, the first few times you do it, you can do it on a calculator, but then you need to remember these values as well. So now this time the function is cos x. Let's draw that function, cos of x. Start at 0, end at 360, and step is supposed to be 90 in this case. We're saying let's plot less values and then just use those values to figure out what the graph looks like. Now, this is what the table looks like for me. At 0, I'm getting 1. At 90, it is 0. At 180, it's -1. At 270, it's 0 again. And at 360, it is 1. Let's plot those values. So we start from 0, and then in the middle here we have 180. Then on the right side we've got 360. Let's break it down further. This is 90 and this is 270. Let's plot those points. Maximum value is 1 and the minimum value is -1. At 0, the y value is 1. At 90, the y value is 0. At 180, the y value is -1. At 270, it is 0 again. And at 360, it is 1 again. Okay, now these are the points that I'm getting from the cos graph, for the cos graph. Okay. Now, what shape do I draw through these points? What shape do I draw through these points? Now, it's not very clear just from these points, okay? But in the exam, you will need to be able to do it using these points. How would you do that? You would remember the shape of the graph. You need to remember the shape of the graph. The first time you do it, you can actually do it using some more points as well. But then remember that the cos graph is going to look like this. The cos graph looks like this. This is the shape of the cos graph. Sine graph was this. Sine graph started from 0. It went up to 1 and then came back to 0 and then -1 and then back to 0. Right? So the sine graph went like this: 0, 1, 0, -1, 0. Cos graph goes like this: 1, 0, -1, 0, 1. These are the same shapes. If you were to extend them, they look exactly the same, right? The shape is exactly the same, but the starting points are different. Sine graph starts from 0. Cos graph starts from 1. That's the only difference between these two graphs, right? So sine graph is starting from 1. Cos graph is actually starting from this point, from 1 onward. So that's why it looks like this. So once you have these points, you can draw a curve like this through these points. The curve goes like this first, and then at 90, it changes direction and starts going like this. And then it goes like this. And then it changes direction again to go this way. That's what the cos graph is going to look like. Okay. Now, the first time you do it, you can take some more points as well if you want. So for example, at 45 degrees, you would see that this is going to give you 0.7. At 135, this is going to give you -0.7. At 225, it's going to give you -0.7 again. At 315, it's going to give you 0.7. But it will be hard to memorize these values, right? This is just for the first time you do it using a calculator, that you understand, okay, this is what the shape of the graph looks like, because this is going to be 0.7 here, and then -0.7 here, and -0.7 here again, and then 0.7 here again, right? So the first time you do it, you can take some more points like this, but then eventually you need to be able to draw it without using a calculator. And for that, these are the points that you need to remember, that at 0, the function has a value of 1, and then it goes to 0, then it goes to -1, and then it goes to 0 again. And then finally, it goes back to 1. Okay, so you need to remember these values and the shape of the graph. Sine graph looks like this, and cos graph looks like this. Okay, again, in IGCSE, this is all that you would need to know: how to draw these graphs, sine x and cos x. Okay, and you can just memorize these graphs. Memorize the shape of the graph, memorize these points. Sine starts from 0, goes to 1, 0, -1, 0. Okay, 0, 1, 0, -1, 0. Cos graph, it goes like this. It starts from 1, goes to 0, and then -1, 0, and 1 again. Okay, you need to memorize these points: 1, 0, -1, 0, 1. Sine starts from 1. Sorry, sine starts from 0. Cos starts from 1. Remember that. Okay? Sine starts from 0. Cos starts from 1. Then finally, let's think about the tan graph and see what that looks like. Y equals tan of x graph. Let's see what this looks like now. Now for tan graph, you will need to take an interval of 45 degrees. Okay. For tan, you will need an interval of 45 degrees. Let's see what that looks like. It'll be the same table as far as the x values are concerned. And this is the table that we have. Okay. So now we have tan of x. Now this graph has a different shape. Let's understand what this is going to look like now. On the horizontal axis, you have x. On the vertical axis, you have y. Again, the first time you do it, to try to understand what the shape looks like, and you can do it using a calculator and see what that gives you. Let's make a table for the tan function now. So instead of cos, we can have tan here, tan of x. Start at 0. In tan, it's important to take a step of 45 instead of 90, because otherwise you would not get enough points. Start 0, end 360, step of 45. Okay, so this is the table that I'm getting when I do that. At 0, I'm getting 0. Y value is 0. When x is 45, y value is 1. When x is 90, we are getting an error. What does that mean? Error means that the tan function is undefined at this point. When x is 90, y is undefined. All right. Okay, let's go on. We will understand what that means in a moment. At 135, y value is -1. When x is 180, the y value is 0. When x is 225, the y value is 1. And then at 270, it's undefined again. At 315, it is -1. And at 360, it is 0. How do you draw this graph now? Now you see, in case of sine and cos, the maximum value was 1. The minimum value was -1. Right? In case of sine and cos, these were the maximum and minimum values. But now, what about tan? How do you think of tan now? We have 0 and we have 1, but then it's undefined. What does that mean? In order to draw the tan graph, you can again label your x-axis like this. You're going from 0 to 360. Let's break it down further. You have 180 here, and then in the middle, you've got 90. On the right side in the middle, you have 270. And if you break it down further, this is 45, this is 135, 225, and 315. Now, what you would do would be the values that are undefined. At 90, it is undefined, and at 270, it is undefined. Skip those values for now, and let's plot everything else. At 0, you're getting 0. Okay, let's plot that. Now, in this case, I'm going to take a smaller scale on the y-axis. Let's say this is 1, and this is -1. At 0, we have 0. At 45, y is 1. At 90, it's undefined. Skip that for now. At 135, it's -1. At 180, it's 0. At 225, it's 1 again. At 270, it's undefined. We skip that. At 315, it's -1. And at 360, it is 0 again. Now at 90 and 270, the graph is undefined. What does that mean? If the function is undefined, that means there's going to be no y value when x is 90, and there's no y value when x is 270. So what you do is, at the points when you have an error, you draw a vertical line like this. You draw a vertical line like this. Now, this line we draw as a dotted line generally. Dotted line or a dashed line, it would look something like this. Okay. Now, let me explain what that means in a moment. You will draw this vertical line at both 90 and at 270 because these are the 2 points when the function is undefined. We draw another vertical line at 270. This is what it looks like. You have another vertical line here. Let's make it dashed as well. Okay, so we have these two vertical lines like this. Okay, now since the graph is undefined at these 2 points, the graph cannot cross these lines. Okay, this looks like it is not a vertical line, it's a bit slanted, so I'll just redraw that quickly. Okay, so I have this vertical line at 270. Let's make it dotted as well. Now the graph cannot have any y value at these x values. That means the graph is not going to cross these points, cross these two lines. Okay, it's going to the graph is going to be going to occur in multiple parts. Okay, now what happens close to these lines? What happens close to when you go to 90 and what happens close to 270? Again, when you're doing it the first time, you can try to understand it using a calculator and see what that looks like. At 90, tan is undefined. Now you can confirm that as well. If you put tan of 90 in your calculator, you get an error for that. Okay, tan of 90 is undefined. But in order to understand what the graph is going to look like, you can take some values close to 90. For example, if I take tan of 85, for instance, okay, at tan of 85, so some value that's slightly to the left of 90, the y value is 11. So that's a large y value. It might be somewhere here, let's say. Okay, let's go closer and closer to 90. Let's say 89. What's that value? 57. Okay. And then tan of 89.9, 573. Tan of 89.999. The values are getting larger and larger. They're getting bigger and bigger. So at tan 90, at a value of 90, the tan is undefined. However, slightly before that, it's a very large negative y value. So what that means is, as you get closer to 90, the graph is going to go in the upwards direction in this case, and it's going to look like this. You start from 0, you go to 1, and then the graph goes like this. The graph goes like this as it gets closer to 90, such that it keeps getting closer and closer to this vertical line, but never actually meets that line. Now, this line has the name, these two vertical lines, they have a name, although it's not necessary that you know that name, but you will come across this in some books and also later on in A-level. This line is known as an asymptote. Okay, now this is the line that the graph is going to get closer and closer to, but never actually touch, never actually meet this graph, meet this graph, meet this graph, yeah, meet this line. This is what the graph looks like on the left side. Okay, now what happens on the right side? If you go slightly to the right of 90 on this side of the line, what happens on that side? You can try, for instance, tan of 90.01. You see, you're getting a very large negative value. So to the right of 90, the graph is going to go in the negative direction. Again, it will be an extremely large negative value going like this. This is what the graph looks like on the left side. And then the same pattern continues. Whenever you get closer to these, whenever you get close to these asymptotes, what happens is the graph is either going to go in the upwards direction towards positive infinity, or in the downward direction towards negative infinity. So the graph shape is going to be either like this or like this, going upwards or going downwards, close to these lines where the function is undefined. So now that you understand that, you can look at the pattern and see what the shape of the graph is going to be close to those lines. So on the right side now, as you go to the right of 180, this point is above the curve right now. So if you join it like this, now beyond this point, as you get closer to the asymptote, this vertical line, the graph is going to go on the upwards direction like this. And then similarly on the right side of 270, you can see you have one point here and have another point here. And we know close to that vertical line, the graph is either going to go up or down. Now, what does it look like on the right side? Since you have one point here, the shape is going to look like this, that the graph goes towards negative infinity like this. That's what the graph of tan function looks like. It occurs in multiple parts like this. You have one part here from 0 to 90, and then 90 to 270 is another part. 270 to 360 is another part. It occurs in three different parts here. Why? Because the graph was broken at 90 and 270 because those two values are giving us errors. So the graph cannot exist at 90 and 270. So it basically gets broken at those points. Okay. Now, how do you draw tan graphs without a calculator? You will need to remember these values. Now, how do you remember them? You would remember the shape and remember that the y values can only be 0, 1, minus 1. These are the only values that you have here. 0, 1, and minus 1. These are the only possible values of tan for these intervals. For an interval of 45 degrees, you start at 0, and then at 45 it becomes 1. At 90 it's undefined. That means it's going to go up like this. Okay. And then from 90 to 180, it goes from -1, 0, 1, and then again -1, 0. So the values are going to follow the same pattern: 0, 1, -1, 0, 1, -1, 0. Okay. And then at 90 or 270, it's undefined. You need to remember that it's undefined at these two particular values of x. If it's in the calculator paper, it's easier to figure out. You can do this. You can make a table on your calculator. Otherwise, you will need to be able to recall all of these values. Okay. Now, this will mostly come in the calculator paper, the sketching part. So you will be able to use your calculator for this, but just in case, you should remember the shape of the graph so that you can draw it directly as well. In the syllabus, it explicitly says that you need to be able to recall just these values, which are these values of sine, cos, and tan, 0, 30, 45, 60, and 90. But they can still ask you to sketch a graph. If they ask you to sketch a graph, even if you're not able to show exact values, this is what you should be able to do, that the shape of the graph looks roughly like this. You have one part of the graph here, and another part in the middle from 90 to 270, and then another part here from 270 to 360, This is something that you will need to remember. Okay. Unfortunately, since you cannot use a calculator in one of the papers, if it comes there, you will need to be able to draw it without the calculator directly like this. But that's the shape of the graph. Now you need to remember these values that you have on these graphs for sine and cos in particular. Sine starts from 0, cos starts from 1. Remember that. Remember the shape of the sine graph, the shape of the cos graph, and the shape of the tan graph so that you're able to draw them directly. And the next class, this is one last thing that we will be discussing, and that is solving equations. Solving trigonometric equations. That's what you want to do in the next class. But that's it for today. I hope that makes sense. I'll see you again in the next class then. Allah Hafiz.